So this is the last part about vector, another operation of vector, the one that we call cross product. Okay, so in this lesson, we will learn about what does the cross product represent, what is an easy way to remember the formula for the cross product, what are the properties of cross product, and the application of cross product. Okay. So what is cross product? Okay. Cross product is an operation of two vectors in three-dimensional space that results in another vector which is perpendicular to the two vectors. So from here, we can conclude that the result of two vectors is a vector that perpendicular to the original vectors. Okay, many applications in physics, engineering, and geometry involve finding a vector in space that is orthogonal to two given vectors. So this one related to the first statement about the resulting vectors being perpendicular to the original vectors. And we can see the application in cross product in physics, engineering, and geometry. Because the cross product yields a vector, it is called the vector product, while the dot product is called scalar product because the result of a dot product, the one that we learned in the previous lesson, is scalar. Okay, so this is the summary of what cross product is. So what is the meaning of a cross product? So let's just say that I have two vectors, vector A and vector B, where theta is the angle in between A and B. Now, from the previous slide, we learned that the result of cross product is a vector. That's why we call it a vector product. Okay, the result is a vector which represented by this blue arrow. This blue arrow is the resultant of a cross product A cross B. Another one that we learned that the resultant vector of a cross product is perpendicular with the original vector. So A cross B is perpendicular to B and perpendicular to A. Okay, so this is the direction of the resultant vector. Now, how do you know? How do you determine the direction of the resultant vector? Now, the direction of the resultant vector is determined by the one that we call right-hand rule. Okay, right-hand rule. What is right-hand rule? Right-hand rule can be described like this. Okay, let's just say that I have vector A and vector B. Now you take your right hand and point your four fingers to the first vector or vector A, and then bend your four fingers towards the second vector, and your thumb will show the direction of the cross product. Okay, like this one. Your four fingers point at the first vector, and then you bend it towards the second vector B, and your thumb will point the direction of the cross product. So this is how you determine the direction of a cross product using right-hand rule. Now you will learn more about this and use this method when you study more about physics. Okay, so this is probably some of the important properties of a cross product. Okay, so we learn about the direction of a cross product, which can be determined by using right-hand rule. How about the magnitude of a cross product? Now, the magnitude of a cross product can be described like this. Okay, let's just say that these two factors can form a parallelogram. Now, the magnitude of a cross product, or the scalar value of the cross product, can be found using the area of this parallelogram. Okay, so this is the direction and the magnitude of a cross product. One thing about cross product that it only applies in three-dimensional space. Okay, so this is the some of the properties about cross product, which kind of the most important thing that you should remember about cross product. Okay, so we have learned about cross product and its representation geometrically, about its direction and its magnitude. Now we will find the cross product of two factors and its representation in the basis factor. Okay, let's just say that I have two factors, A and factor B, whose component in XYZ direction, IJK, is A1, A2, A3, B1, B2, and B3. Okay, so this is the component of each factors. Now, the easy way to find the cross product of A and B is to find the determinant of its matrix. So it's like we arrange 3 times 3 matrix like this, where the component of each row is arranged like this. The first row is filled with its basis factor I, J, and K. The second row filled with the component from the first factor, in this case factor A, A1, A2, and A3. And the third row is filled with the component of the second factor, or factor B, B1, B2, and B3. So if you want to find B cross A, so the second row will be filled with the component of factor B, and the third row will be filled with the component of factor A. Okay, this is how you arrange the matrix. And to find the determinant of this matrix, we have learned in the previous semester to find the determinant using the Sarus method, like this. Okay, so you multiply it's like this. You copy the first two columns like this, and then you make a line in this direction, you add, and in this direction you subtract. Okay, or to summarize this, okay, the calculation become like this. So in I direction is A2 times B3 subtract by A3 times B2, plus in the J direction A3 times B1 subtract by A1 times B3, plus in the K direction A1 times B2 subtract by A2 times B1. Okay, so this is the resultant factor of A cross B in its basis factor. Okay, so as I said earlier that the magnitude of a cross product can be described as the area of a parallelogram formed by the two factors A and factor B, like this. This is the parallelogram. Okay, as you remember, the area of parallelogram is base times height. Okay, where its base is the length of factor A and its height. At its height, you can find its height using the trigonometric ratio. As you remember that sine theta is T divided by AD, or in this case, that T is equal to the length of vector B multiplied by sine theta. Okay, if I replace T, I get A, the length of A, times the length of B sine theta, or the magnitude of A cross B is equal to the magnitude of A times the magnitude of B sine theta, where theta is the angle in between the two factors. Okay, now let's see some properties of cross product. The first one, it doesn't apply commutative rule. So A cross B is not the same as B cross A. As you know that the result of a cross product is a vector with its own direction. Okay, so A cross B is not the same as B cross A. However, A cross B is equal to negative B cross A. Okay. The second one, if a cross product being multiplied with itself, so A cross A, B cross B, the answer is 0, where factor A and factor B is not 0. Okay, this is consistent with the formula of its magnitude, where the magnitude of A cross B is AB sine theta. If the factor is the same, so theta is equal to 0. So sine 0 equals to 0. So A cross A and B cross B equals to 0. The third one, cross product applies the distributive rule. A cross B plus C equals to A cross B plus A cross C. Okay. The fourth one, it's the combination between dot product and cross product. So A dot B cross C is equal to A cross B dot C. The fifth one, A cross B cross C equals to A dot CB subtract by A dot B C. Okay, you will probably use a lot of these properties in the later grade or in college. In this grade, we will not use a lot of these properties. We will only use the most important one. Okay, so this is for just for your own knowledge. Okay, the sixth one is cross product in its basis factor. I will conclude it like this. This is the table of a cross product between basis factor. I cross I is 0. J cross J is 0. K cross K is 0. Okay, if the factor is the same, the cross product is equal to 0. What if the factor is different? I cross J is K. I cross k is negative j. J cross I is negative k. J cross k is I. K cross I is j, and k cross j is negative I. Now, what is the easy way to find or to memorize the cross product in basis vector? Is using this kind of circle like this. This is I, J, and K, and the direction of the circle is clockwise. Okay, so if I cross J, the answer is K. K cross I, the answer is J. Okay, what happens if we cross it in reverse? J cross I, the answer is K, but in opposite direction, so negative K. Okay, so this is some of the properties of cross product. Okay, so now let's see the cross product application. And the first one here is the most simple one, is to find the area of a triangle. Okay, let's just say that I have a triangle ABC where one of the angle is theta here. Okay, as you remember, to find the area of a triangle in trigonometry lesson, that the area of triangle is 1/2 times the length of AB times the length of AC times sine theta. Okay, here you remember that AB times AC sine theta is the magnitude of a cross product between AB and AC. So the area of a triangle ABC is 1/2 multiplied by the magnitude of cross product between AB and AC. Okay, so now let's see some of the application of the cross product. Okay, as you know, the result of a cross product is a vector perpendicular to the vectors being crossed. So if you want to construct an orthogonal vectors, now you may use the cross product to do it. Okay, the other one, the one that we discussed earlier, is to find the area of a triangle or parallelogram. Now here I want to show you some more about the cross product application, such as to find the volume of parallel piped. Okay, here it's like a parallelogram in a three-dimensional form. Okay, in three-dimensional figure. So to find this, the volume of this figure is using the cross product. Okay, the other one is in physics. Okay, cross product is used in magnetic and electric fields like this. So you will see more of this in detailed in physics lesson. Okay, this one also to find the angular velocity, and this one is to find the moment of force or torque. Okay, you will learn about this on physics, and this is just the general description about it, but you will learn about this more in physics lesson. Okay, this is some of the application of cross product in physics lesson.